This Equipment World video is brought to you by Chevron Delo 600 ADF Ultra Low Ash Diesel Engine Oil. It's time to kick some ash. Hey guys, welcome back to The Dirt, the video podcast that's geared towards bringing you discussions and news regarding heavy equipment and just general topics in the construction industry. I'm your host Brian, and today we're going to be talking about one of the most underappreciated, generally neglected fluids on your job site. We're going to be talking about coolant. And yes, I know this isn't the sexiest topic out there, but I think it's one that needs to be covered because it isn't ever covered. If you're anything like the contractors that I've worked for in the past, coolant is one of those fluids that you only worry about in two circumstances. One, if you're having overheating issues, or two, if it's the week before you get a big freeze through and you go through all your machines making sure that you're not going to have any issues because they are low on actual coolant. Outside of that, we really, in this industry, generally ignore the coolant tank. And that's something that if you did with any of your other fluids, you would get raked over the coals for it. But as an industry, we tend to undervalue the coolant that goes in our machines to keep them running smoothly. Today, I'm going to be joined by Lawrence Wong from Chevron. He's a technical product specialist that specializes in the cooling side of the business, and he's going to answer some questions I've got about coolants and just general maintenance when it comes to servicing your machine's coolant. But before we get into that, I want to take a second to tell you about the sponsor of this video, Chevron Lubricants. Protecting your diesel engine and its exhaust aftertreatment system has traditionally been seen as an either-or proposition when it comes to choosing the engine oil that's going to protect your system. And that's exactly why Chevron spent more than a decade of R&D work developing a no-compromise formulation. Now, I don't have to tell you why a clogged DPF is bad news, but here's the real kick in the pants. 90% of that ash clogging up your DPF and then upping your fuel and maintenance costs, it comes from your engine oil. You might be thinking, why don't they make an engine oil with less ash in it then? You'll be happy to learn that Chevron agrees with you. They've developed a new ultra low ash diesel engine oil that is specifically designed to combat DPF ash clogging. Delo 600 ADF with OmniMax technology cuts sulfate ash by 60%, radically reducing the rate of DPF clogging and extending the DPF service life by 2.5 times. Before you had to choose between protecting your engine or your aftertreatment system. Now you don't. Delo 600 ADF with OmniMax technology. It's time to kick some ash. So without further ado, Lawrence, welcome to the show and thank you for your time today.
Oh, you're welcome. Thanks for having me.
Absolutely. So my first question is, as contractors move into the summer months and they start having to consider doing some coolant adjustments on their machines, what should equipment managers and owners really be considering when it comes to coolants and lubricants for the summer months?
The main thing I would say to most of these managers is, have a good PM program or preventative maintenance program, right? The obvious checks on fluids and engine oils, making sure that they're topped off, that they're at the appropriate levels, making sure that they're in serviceable condition is all well and good. But I think what I've seen out there is that oftentimes coolants is kind of an afterthought. So making sure that coolants is included in their PM program is an important part of that preparing for summer and the heat of summer. Because I've actually seen out there where 40%, if not more, of engine-related problems are attributed to the cooling system.
Wow.
So yeah, it was a number that really surprised me. But I've seen that from multiple sources. So yeah, making sure your coolant or cooling system is included as part of your PM maintenance is a good thing. Good place to start.
Well, that's a perfect lead into my next question is, what are some of the signs of a piece of equipment when it has not had the proper maintenance done on the coolant side of the machine? We're all familiar with oil and lubricants, but what specific to coolant is going to show up?
Warning light?
That's right, and a big buzzer?
yeah, exactly. You may get your piece of equipment overheating, so running a little hotter, stuff like that. So I guess as part of the PM program, if you were to actually check your coolant levels, there's like two super simple checks you can do on the coolant is like, check for the pH and check for the freezing point of your coolant. Those are two really simple checks that you can do. Doesn't take much time. The pH, if it's too high or too low, could be an indicator that, your additive levels are inadequate. That may be a warning sign that, hey, pull a coolant sample, let's get it tested, and just double check it. The other thing is, I mentioned freeze point. I recommend most people get a refractometer to check the freeze point instead of using, the coolant test strips. And the reason being is that a refractometer is more accurate than using test strips. But if your freeze point is off, if it's too high or even too low, it could mean you have too much water or too little water in the system. And in the summertime, having that right balance could mean, not overheating. So.
Yeah, that's actually a question I hadn't thought of before. I've always been in the school of thought that it's better to have too much coolant and too little water because at least you're going to be covered in the wintertime. What are some of the negative effects of having too much coolant in the system?
Yeah, so if you have too much coolant and too little water, let's take a step back. So water is probably one of the best known heat transfer fluids we have out there. Right, it's really efficient at moving heat away from the engine.
Sure.
So, in the summertime, if you want to maximize the heat transfer capability of your coolant, you'll want to run a little bit more water. So running like a 40-60 will give you more heat transfer capability. You'll tend to run a few degrees cooler and potentially avoid overheating. And then avoiding, downtime or derating of your equipment. Yeah. Oh, and since we're talking about, 40, 60, 60, 40, 50, 50, just to clarify, it's glycol and then water. So a 40, 60 would be 40% glycol, 60% water. Yeah.
Gotcha. Okay.
Yeah. But don't go lower than that.
Oh, so that's when you start running into issues?
Yeah. So, most coolants, when they're formulated, they meet certain industry specifications. And if you talk about the couple of main industry specs, ASTM D3306 and 6210, they test the coolant packages and they test for stuff like, protection against corrosion and stuff like that. And essentially the tests are designed to make sure a coolant is good between 40 and 60, blend to up to a 60 and 40. So anywhere in between that is good.
So that kind of leads into on machines coming from manufacturers. What are some of the differences between the types of coolants that OEMs are putting into their machines?
Okay, yeah. So, OEMs, different OEMs recommend different types of coolant. You have some OEMs recommending traditional or conventional type coolants. There's other OEMs that are recommending organic acid technology coolants or OAT. I think you've probably heard of that. And then you have kind of a hybrid organic acid technology coolant or a HOAT, H-O-A-T. And so, your conventional coolants generally have like a silicate or phosphate base in them. They're generally green or purple in color. Your organic acid technology coolants are formulated with carboxylic acids or azoles. They're generally red or orange in color. The difference between the two, the conventional coolant technologies, they'll lay down a protective layer across all the metal surfaces in the cooling system, which protects the metals from corrosion. The problem with that is that, with a layer between the metal and the coolant, you're impeding heat exchange. So you may run a few degrees warmer But if you have an oat coolant, how it works is it lays down a protective layer only where it detects corrosion occurring, and so you don't have that layer between the metal and the coolant all throughout the system.
So you get better heat transfer.
Exactly, and then you'll run a few degrees cooler. And the difference between the two, in addition to operating temperature or heat transfer efficiency, is that where was I going with this? So by laying down a protective layer across all the metal surfaces, it requires a lot more additive, right? Because it's being consumed,
and so your service the entire inside.
Yeah, so your service life of that coolant is a lot shorter because you're depleting all the coolant, or you're depleting all the additive within the coolant. Whereas in an oat coolant, where it's only protecting the metal surfaces where it's needed, it's the additive depletion is a lot slower. So you'll get much longer service lives. So 500,000 miles, 750, 1 million miles.
Wow.
10,000 hours, 20,000 hours, compared to a conventional coolant.
So now that I know some official formal industry terms, can you mix oats, and conventional, or do they need to be fully flushed before you do a swap out? And I guess my bigger question is, can you take a legacy piece of equipment from the 80s and switch the type of coolants, or is it only newer machines that are designed to work with some of the newer technology?
Yeah, so I always tell people, follow what your OEM recommends. That's your safest bet. If it's out of warranty, then it would depend on the type of equipment, and I say always consult with your fluid supplier in terms of I guess upgrading from a previous coolant to a newer coolant. But let's see. In terms of mixing conventional and oat coolants, I'd say it's probably not a good idea to mix the two. For one, there are different additive systems in the two, right? And by mixing the two, you're essentially diluting the additives in both of those coolants, and those additives are there to help protect the system. So by diluting those additives, you're essentially reducing the protection you're getting in your cooling system. And then secondly, by mixing the two conventional and oat coolants, you run the risk of gel formation in the system. And then, if as gel accumulates in your system, you run the risk of clogging the system. And if you clog the system, then the coolant can't circulate.
You have major issues on your hands.
Yeah, and then it, if you lose circulation, you lose cooling capability, and you overheat, and then you're screwed.
Yeah. So, okay, interesting. So, I guess my next question would be, even if you're not mixing coolant types, but you know what? We're going to turn this into a two-part question. How often would you recommend doing a full coolant switchover? So instead of just topping off for the year, how often should you physically drain the machine and what's the word I'm going for? Refill it with a new batch of coolant?
So again, I think going back to what I said previously, always follow your OEM guidelines. There's some OEMs out there that say, okay, use it for this many hours and then change it out. But I know that, there are fleets out there that want to maximize, the service life of their fluids. It saves on maintenance time. It saves on maintenance costs, fluid costs,
Sure.
et cetera. So, as part of the PM process, I think, checking your fluid levels, running analysis on your coolants, and monitoring kind of the additive levels, the condition of your coolant. I think all of that plays a part into how long, you can actually run the coolant. There are coolants out there from various companies that will say, okay, good for 500,000 miles, good for 750, 1 million. There's a coolant out there that goes over 1 million miles.
Wow.
But I think that's all predicated on the fact that you're monitoring that coolant And if at any point, that coolant isn't looking too good, make sure you address that issue. But
So
I think
if
it goes
I've
back
decided,
to,
go ahead.
well, I was just going to say, I think it goes back to, just like on the engine oil side, right? Making sure that your engine oil is in good condition will maximize the service life of that oil.
Sure. That makes sense. So now if I am an equipment manager and I've decided, look, this piece of equipment here is due for, we're gonna drain the coolant tank and refill it. Do you recommend just doing a drain, or do you need to do a full system flush in order for that to be truly effective?
Yeah, so I think best in class coolant conversion, so to speak, or refill, I would say is drain, flush, and fill. And what that does is it helps ensure that there's no issues with the new coolant that you're putting into the system, right? When you drain a cooling system, you at any one time you'll end up with 10% of the old coolant still in the system. And if that old coolant had any issues with it, if it was contaminated or if it was depleted, essentially you're just carrying those issues into the new coolant, and you don't want to do that. And then you risk diluting the new coolant a little bit. So yeah, I will say best in class's recommendation would be to drain, flush, and fill.
Gotcha. Makes perfect sense. So you had mentioned a refractometer. Outside of that, are there other methods that equipment managers can use to kind of gauge the effectiveness of their coolants in their equipment?
Yeah, so I said that there's the two main checks you would do, checking for pH and freeze point. So those are two easy checks. If either one of those two or both are kind of outside the normal range of the coolant that you have in the system, then pull that coolant out, get a small sample and send it out for coolant analysis. And I think different coolant suppliers may have a coolant analysis program out there. So if you suspect that there's something going on with your system, you pull a sample, send it out. And a lot of these programs will come with a little container for you to put your coolant in. It's got a little sticker and a little mailing box, and you ship it off, and they send you the results back in a few days. And that's an awesome tool for maintenance managers because they can do a quick check. If they suspect something, they can look at that report and say, oh, my additive levels are a little low. Or it also gives you a double check on your pH and your freeze point. It can also tell you, if the coolant is contaminated with something. Maybe somebody, let's say you have an over-the-road fleet. A lot of times those guys will travel in their rigs with an extra bottle of coolant, but it may not be what's in the engine, and they'll just use it because it's easy, and they'll top off, or they'll just buy whatever is convenient along the road. So it'll tell you if it's contaminated, if it's got a third-party coolant in it, if your freeze point or pH are truly off, because a lot of times test strips are a good first check, but they may not always be as accurate.
They don't go in depth. Sure.
Yeah. So.
And I know this probably also accounts for all of the people, as we all know in the industry, who may or may not use an old oil jug to throw some coolant in to get it over to the machine. So you get a little motor oil mixed in there.
Exactly.
So I'm sure it checks for all of that as well.
Yeah, exactly. For sure. I've seen that a lot. Yeah.
Yeah, I would imagine that's a pretty common practice that I saw on the job that, it's like, ooh, you dumped it out for the most part. We ought to be good.
Yeah. Yeah, I like for the most part.
Yeah, for the most part, we're good. Yeah. My next question is, and this is, me being originally from Texas, I do notice some differences from northern to southern states. What are some main differences that you need to be concerned with when it comes to coolant, both in the prepping for summer and prepping for winter months?
Yeah, so I think, with a lot of modern fluids, they have much wider operating ranges in terms of temperature than old fluids and coolants did, right? So short of making sure that your fluids are in good serviceable condition and the systems are all topped off, oftentimes there's not a whole lot they need to do. But you have the extremes, right? So like you were saying, you're from Texas, or if you go even further south, like towards the equator, in the summer months, you could see extended periods of times with super hot temperatures. So you may want to switch to, like we were talking about, a 40-60, where you have a higher water content, and you get a little better increased heat transfer capability. So you may want to run that 40-60 during the summer months. And then vice versa, or on the flip side of that, like in the winter months, if you're in the far north, like in Alaska, or somewhere up in the Arctic, right, in the winter months, you may see super low temperatures, and so you may want to run something that is a 60-40. You have more glycol, less water, but that increase in glycol will give you more freeze point protection. So things like that are some couple of things to consider.
And this is, I don't want to put you on the spot, and I also don't want anyone to take this as, take it to heart, and this is the standard in the industry, but is there kind of a general rule for temperature-wise when you get down into the lows of when you really need to consider going from a 50-50 down to a 60-40? Or is that kind of just dependent upon the manufacturer of the coolant and probably what the OEM recommends for the machine?
Yeah, I think the biggest consideration would be where you're at geographically, right? Because a 50-50 coolant theoretically is good down to about minus 36, minus 37 degrees, right? So that's pretty cold. But like I was saying, if you're up in the Arctic, and you're getting down to minus 60 degrees, you're going to need that extra freeze protection. So you may want to increase or change out that fluid with something with more freeze protection. And then like on the flip side of that, if it's super hot, you may want to get more heat transfer capability.
Well, this has been super informational. I actually, it's funny that you talked about this being one of the more neglected fluids. I said the exact same thing on the intro. This is just something that most contractors don't really spend much thought or time on, but this has been super informational and educational. I really appreciate you being on the show today.
Oh, you're welcome. Yeah, it definitely, that's a point I try to make to a lot of maintenance managers. And, when we get out there, we try to educate them and, tell them it doesn't require a whole lot of time, but it'll buy you a lot of peace of mind.
So there you have it. We have managed to do an entire, 20, 30 minutes on coolants. And, I'm a bit biased here, but I think we kept it at least semi-interesting here. And I will say I genuinely, legitimately learned something today, because coolants is just one of those things that we don't really care about until there's an issue with it. So I've never taken the time to understand how coolants work. So having Lawrence on was really educational and informative just to me. So I hope this has helped you guys out and giving you a little direction on what to look for as you go forward doing preventative maintenance with your coolant systems. As always, thanks for watching, and we'll catch you guys next week on The Dirt.